Okay, so this is washer and disc, daily grade number 2. This is the one where you had to draw the diagram, which is really important because a lot of times they don't give you the diagram in college, sometimes on homework, maybe on part of the test, but there is always some where you have to provide the diagram. So we have all of these restrictions here, and it's rotated about the x-axis. So let's draw off what we have. So I have all the way to x is equal to 2, 0, 0, and y squared. Okay? So let's do, so this is y equals 0. And then, of course, this is x equals 0. And I know this is terrible, but it's very hard to draw straight lines on here. But I know you guys know. And then we have x is equal to 2. Oh. And then we have our function. Y is equal to x squared. So it's obviously going to be from 0 to 2. So at 0, so what I'm saying here is making like a t-chart. When x is 0, y is 0. And then it's going to stop at 2 because it tells me to stop at 2. Y is 4. So we have 1, 3, 4. So it goes through 0, 0 and 2, 4. And remember, it's a parabola, so it looks like this. So if it's talking about the area bound by all 4 of these, that's this area right there. Okay? So remember that when we're talking about washer-disc method, 2 things. The first is I'm rotating about the x-axis, which is here, and all of my area touches my x-axis, which means this is going to be a disc, right? It's going to be a solid piece, no hole in the middle, a solid piece. The second thing that I want you to remember is that when we're dividing this up into our little rectangles, that the radius runs from the axis of rotation to the outside of the function. So that means that my radius runs like this. So it's going to look like this, which means that the thickness, the width of that radius is delta x, because left to right is the x direction, which tells me 2 things. First, it tells me how to figure out the length of my radius, which is going to be from 0 to the function x squared. And it also tells me that I should be integrating with respect to x, because delta x means dx. Okay? So remember that area for a disk is equal to pi r squared. So area is equal to pi. My radius, because my function, we're talking about from the distance from 0, it's just going to be the function, which is going to be x squared, quantity squared, which means my area is pi x to the 4th. So remember that we find volume by taking the integral of area. So I have the integral. My bounds have to be in the same value as my function. So my function is x, my bounds have to be in x, which means I go from 0 to 2 of pi x to the 4th dx. So I'm going to move my pi out. Right? So I have pi times x to the 5th over 5 evaluated from 0 to 2. So I'm going to pull that 1/5 out. So I have pi over 5 of 2 to the 5th minus 0 to the 5th, which means I have 32 pi over 5. Okay? So here we go again. We have these functions, and it's rotated about the x-axis. So 0, x1, that's all first quadrant. So I'm going to do it like this. So I have 1, 2, and this is going to have to be smaller. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have y is equal to 0. And then we have x is equal to 1. And x is equal to 2. And then we have our function. So again, I know it has to be between the two blue and above the 0. So I'm going to just plug in 1 and 2. So if I was going to make a t-chart for this function, which you don't have to do, I know it's just mental, but 1 cubed is 1 plus 1 is 2. So it's going to go through 1. It's very hard to make a dot on here. 1, 2. And if I plug in 2, 2 cubed is 8 plus 1 is 9. So 2, 9. It's going to be this highest point here. Remember that cubic function kind of has that snaky, so it's going to look like this and come through plus 1 and then kind of look like that, which means that the area that I'm talking about rotating has to be between all of these, which again is right here. And we are rotating about the x-axis. So my area touches, so this is again a disk. Again, remember the radius runs from the center, which is going to be the axis of rotation, to the outside, which means it looks like this, which means it's delta x, because my width of my rectangle is going to be determined from left to right. So it's delta x. So area is equal to pi r squared. So area, my radius is 1 plus x cubed, quantity squared. So we know we need to multiply this out in order to take the derivative. So square the first term, twice the product, and square the last term. Okay. And volume is the integral of area. And if my function is in terms of x, then I'm going to go and put my pi on the outside. If my function is in terms of x, my bounds have to be in terms of x, which would be 1 to 2 of 1 plus 2x cubed plus x to the 6th dx. So we have pi. Sorry about that. So the antiderivative of 1 is x plus 2x to the 4th divided by 4 plus x to the 7th divided by 7 from 1 to 2. So I have pi, and I'm going to reduce this in my step. So I have 2 plus 1/2 times 2 to the 4th plus 2 to the 7th over 7 minus the whole quantity of 1 plus 1/2 plus 1/7, because 1 to any power is 1. So I have pi times so I'm kind of out of room here, but this is just a lot of calculation, right? So we have 2 plus, I'll do some of it, but I don't think I'm going to have enough room to do all of it. I'm going to try. So this would make this 2 to the 3rd, because if you have 1 down here and 4 up here, that makes 2 to the 3rd, which is 8, plus 2 to the 7th is 128 over 7, minus 1 plus 1/2 is 3 over 2. So I'm going to do that. 1 over 7. I might have enough room, maybe. 10 plus 128 over 7 minus 3 over 2 minus 1 over 7. And I'm going to put these two together and then the sevenths together. That should make my life a little bit easier. So this would be 20 over 2. So that would be 17 over 2. And then 128 minus 1 would be 127 over 7. And then get a common denominator of, it'd have to be 14, I guess, times 7. $14, 5, 2, 54, and that would be 194, 119 over 4 plus 254 over 14, sorry. Still times pi would be 373 over 14 pi. Okay. Okay, so we have 3 functions this time, and we're rotated about the y-axis. So we have then y is 1, x is 0, and y is equal to x cubed. So we have 1, 2, 1, 2. Oh, that's not good. 1. How about that? Slightly better. So we have x is equal to 0. So here, x is equal to 0. And then we have y is equal to 1. And then we have the cubic function, y is equal to x cubed. So I'm going to start with x is equal to 0, because it tells me that's where I have to start. So then y is 0. So then I need to know where y is going to be 1. Well, if y is 1, x has to be 1, so it goes through 1, 1. So remember that cubic is that snaky looking thing, so it looks something like that. So then if we're talking about the area, be here, and we're rotating about the y-axis. So again, remember the radius runs from the center, which is going to be your axis of rotation, to the outside of the function, which means my little chunks are going to run this way. Well, if my thickness is up and down, that means delta y is going to run my thickness, which means I'm integrating with respect to y. It also means that because my area touches my axis of rotation throughout the entire area, one whole side of the area, that this is also going to be a disk. Okay? So area in terms of y is equal to pi r squared. So it's the distance from y equals 0 to the function, right? So if my function has to be in terms of y, that means I need x equals. So y cubed, so this means y to the 1/3 is equal to x. So that means pi times y to the 1/3 squared. So a y is equal to pi times y to the 2/3. So remember, volume is equal to the integral of area. So I'm going to put my pi on the outside. So if my function is in terms of y, my bounds have to be in terms of y. So I'm going to go from 0 to 1, which again, this one you couldn't mess up because the bounds are the same both ways. But to be clear, if your function is in terms of y, then your bounds have to be in terms of y. Y to the 2/3 dy. So we have pi times y, so we add 1, so 5/3 divided by 5/3. Evaluated from 0 to 1. So I'm going to bring my 3/5 out, so I have 3 pi over 5. 1 to the 5/3 minus 0 to the 5/3. It's just going to be 1. So we get 3 pi over 5. Okay. Number 4, so we have y is equal to 1 over x, y is equal to 2, and x is equal to 2 about the x-axis, which is still first quadrant. Convenient. So 1, 2, 1, 2. So y is equal to 2. X is equal to 2. And then y is equal to 1 over x. So when I make my t-chart, I need to know when x is 2 and when y is 2. So when x is 2, y is equal to 1/2. When y is 2, x is equal to 1/2. So when x is 2, y is equal to 1/2. When x is 1/2, y is equal to 2. And then if you need to kind of, this is a curve here, but it should go through 1, 1, like this. So if we're talking about the area bound by all 3 of those functions, that has to be this area here. And it says rotated about the y-axis, which means we're rotating this way, which means my radius runs like this, which is delta y. Okay, but we have a problem because this time I can't define it as the function, because if I define it as the function, then it's talking about this distance here. That's what it will give me if I say my radius is 1 over y. Okay, but that's not what I'm looking for. I'm looking for this distance, which would be 2 minus the function. Okay, so that means my area would be pi times my outside radius squared minus my inside radius squared. So pi, so my outside radius is the thing furthest, the function farthest from my axis of rotation, which is 2, minus my inside function, which is going to be this distance, my inside radius, which is that function, in terms of y. So just to be clear, multiply by x, and then divide by y. So x is equal to 1 over y. So 1 over y squared. So my area would be pi times 4 minus 1 over y squared. So my volume is the integral of area. So I'm going to put my pi on the outside. Remember, whatever my variable my function is in terms of has to be what my bounds are in terms of. So if I'm in terms of y, I have to do y. So that would be from y equals 1/2 here to 2 of 4 minus, and I'm going to go ahead and write this as a negative so that we can take the integral dy. So I have pi times 4y minus add 1, y to the negative 1 divided by negative 1 from 1/2 to 2. So I have pi times, I'm going to go ahead and fix this. So 2 negatives make a positive 1 over y from 1/2 to 2. So I have pi times 4 times 2 plus 1/2 minus 4 times 1/2 plus 1 over 1/2. So that gives me 8 plus 1/2 minus 2. 4 times 1/2 is 2. Multiply by the reciprocal gives me 2 minus 2. So that's going to be 8 times pi, sorry. So 8 minus 2 is 6, minus 2 is 4, plus 1/2 would be 9 over 2, 4.5, 9 pi over 2. Okay, so 5, y is equal to x, y is equal to 2 minus x squared, and x is equal to 0 rotated about the x-axis. Okay, so x equals 0 is pretty easy, so I'll go ahead and put that in. So we know it has to be bound right here. So I know it's in the first quadrant because the other two are going to be in the first quadrant. Well, the linear will be in the first quadrant, and the other one will be in the first and the fourth. But so we're looking at the first quadrant again. So it may be useful to know where those two functions intersect to kind of get an idea of what your graph is going to look like. So I'm going to set them equal to each other. So I have 2 minus x squared is equal to x. So I know it's a quadratic, so I need to get everything on the same side. I prefer my x squared to be positive, so I'm going to move everything over here. Excuse me, x squared plus x minus 2, which gives me x plus 2, x minus 1, which gives me x is equal to negative 2, and x is equal to positive 1. So we clearly don't care about the negative 2 because it has to be greater than 0. So I know they're going to intersect at 1. So this one's going to go through 1, 1. And then this one is going to go through 1, 1. Okay? So let's do... and it's going to go through 0, 0. So y is equal to x. And then x squared here is also going to be 1, 1. But I also need to figure out where it intersects up here. So this is y is equal to 2 minus x squared. So I have x and y. So I knew I needed x is equal to 1, which gave me 1. But I also need x is equal to 0, because that's this function, how it intersects this function. So 2 minus 0 is 2. So 0, 2. Which is here. And remember, this is a downturn parabola. So it looks like this. Right? Which means I'm referring to this area here between all of them. And we're going to rotate around the x-axis. So if I'm rotating around the x-axis, that means my radius runs this direction, which is delta x. So I'm integrating with respect to x. And I have this gap right here, which means that this is a washer. Did I say? I didn't say this one was a washer, but it is. I apologize. My pen is acting crazy, guys. I'm very sorry. Okay. So that means I have area of x, delta x, is equal to pi times radius outside minus radius inside. So I have pi times. So my outside radius is the function farthest from my axis of rotation. So because it's an axis, I'm not going to have that plus or minus stuff. Okay, so that means the green function is 2 minus x squared. So 2 minus x squared minus my inside function, which is just x squared. So I'm going to get this expanded out to get ready to evaluate. So square the first term, twice the product, square the last term. So I'm going to fix it down here because I'm running out of room, is the integral of area. So I have pi times, so if I'm in terms of x, then my bounds have to be in terms of x, which means I'm going from 0 to 1. And combine like terms, I'm going to have x to the 4th minus 3x. Oh, I didn't. This should be 4. It's twice the product of 2 times negative, so it'd be negative 4, which means 4, which means to be negative 5x squared plus 4 dx. So then I have pi x to the 5th divided by 5 minus 5x cubed divided by 3 plus 4x evaluated from 0 to 1. So pi times 1/5 minus 5/3 plus 4 minus 0. So I'm just going to put everything in terms of 15. Just going to make my life easier, so I'm going to multiply by 3. So this will be 3 over 5, and this one will be 5 minus 25 over 15, and then so I have 63 minus 25 is 38 pi over 15. Now you could have combined that a little differently. Makes no difference how you do that algebra part. Just got to combine like terms, whatever makes sense to you. For 6, we have y equals x squared and y equals 2x rotated about the y-axis. So definitely need to figure out where these two, I don't have any of that x equals 0 or y equals 1 to kind of give me an idea of where this is bounded. So the first thing I'm going to do is figure out where these two functions intersect. So I'm going to do x squared is equal to 2x. So x squared minus 2x equals 0. So x times x minus 2. So x is equal to 0 and x is equal to 2. So I'm still in the first quadrant. One, 2. So x squared 0, 2. So y is equal to x squared 0, 4. And y, let me do red, it's a little bit easier to see. Y is equal to 2x, 0, 2. So 0, 4, which we should have expected because that's where they intersect, right? Just making a point. So 1, 2, 3, 4. So they go through 0, 0 and 2, 4. And this is just a matter of knowing that it is a parabola. So it looks like a U, right? And then this is a linear function. So it goes through and it does like this. And we are going to rotate, which means the area that I'm looking at is between the 2, right? And we are rotating about the y-axis. So this is very obviously a disc. I mean a washer, sorry. Okay. So if I'm rotating about the y-axis, means I'm rotating this way. So from my axis of symmetry to my function is my radius, which means it runs this way, which means I need to integrate with respect to y. Okay, because the thickness of my slices is determined by delta y, the change in y, that's up and down. So that means I'm integrating with respect to y. So that means I'm going to have, this one is going to be the square root of y is equal to x, and this one is going to be y over 2 is equal to x. So a of y, is equal to pi times outside radius minus inside radius squared. So pi times, so my outside radius is the farthest function, which is the blue function, which would be y to the 1/2 squared minus my inside function, which is red, which would be y over 2 squared. So a of y is equal to pi times y minus y squared over 4. So volume is the integral of area. I keep doing that, sorry. dy. So I have pi times, so if my function is in terms of y, my bounds have to be in terms of y, which means I'm going from 0 to 4 of y minus y squared over 4 dy. So I have pi y squared over 2 minus y cubed over 12, 4 times 3 is 12, from 0 to 4. So I have pi 4 squared over 2 minus 4 cubed over 12 minus 0. So pi 4 squared is 16 over 2 is 8 minus 4 cubed is 64 over 12 which is 16 over 3. So pi is 24 over 3 minus 16 over 3, which is 8 pi over 3. Last one. Okay, so again, I need to know where these intersect. So I'm going to do x squared is equal to x plus 2. I personally like to keep my squared term positive, so x squared minus x minus 2. So x minus 2, x plus 1. So I have x is equal to 2 and x is equal to negative 1. So we're not bound in just the first quadrant this time. So I know I go negative 1, positive 2. So let's look at the first function. Y equals x squared. I know I need negative 1 and 2. So this negative 1 squared is 1, 2 squared is 4. And again, we know these are going to be the same points, but just for argument's sake, negative 1 and 2. So 1 and 4, just as we expected. So this is a parabola, so it's going to go through negative 1, 1, 2, 3, 4. All right, so negative 1 I truly hate this pen sometimes. All right, so negative 1, 1, and then 2, 4, right? So it's a parabola. Vertex is at the origin. So I'm going to go ahead and mark that so my curve's not too far off. So it looks like this. And then this is a linear function. Oh, that's bad off. So it's going to look like this, right? Which means the area that I want to rotate is here. And we're going to rotate that area around the x-axis, which I obviously have a washer. And if I'm rotating this way, right, then from my axis of rotation to my functions means that I am integrating with respect to x, because my slivers, my rectangles that I'm cutting out, right, are changing with x. So their thickness is left to right, so delta x. So I have area of x is equal to pi times radius outside minus radius inside. So outside radius is the farthest radius. So that is the blue function, which is x plus 2 squared, minus the inside function, which is x squared squared. So I have a of x is equal to pi times x squared plus 4x plus 4 minus x to the 4th. So remember, volume is the integral of area. So pi. So if I'm integrating with respect to x, my bounds have to be with respect to x, which we already found, -1 to 2. And I'm just going to write this in order, negative x to the 4th plus x squared plus 4x plus 4 dx. So volume is equal to pi times negative x to the 5th divided by 5 plus x cubed divided by 3. It's going to be 4x squared divided by 2, so 2x squared plus 4x evaluated from -1 to 2. So volume is equal to pi -2 to the 5th divided by 5 minus 2 cubed divided by 3 plus 2 times 2 squared minus 4 times 2 minus negative of -1 to the 5th over 5 minus negative or plus -1/3 plus 2 minus 4. Okay. A lot of cleanup that I'm not sure I have the space for. So I have pi -32 over 5. Did I just change that sign? I did. Plus 8 over 3. 2 squared is 4 times 2 is 8 minus 8. So 3 negatives is going to give me a -1/5. Negative times a negative is a positive 1/3. Negative times a positive is a -2. A negative times a negative is a plus 4. So we have pi. So 8 minus 8. So -32 over 5 minus 1 would be -33 over 5. 8 plus 1 would be 9 over 3, which is 3. And I'm going to go ahead and fix that. 3 minus 2 would be 1 plus 4. Did I change the sign again? I did. My bad, guys. I just randomly changing signs. That should be a plus. That should be a plus. Alright, so let's start over. The -32 and -1/5 would be -33 over 5. 16 plus 3 is 19. Minus 2 is 17. Plus 4 is 21. So I'm out of room, so you get a common denominator of 5, which would be 105 minus 33, which would be 72 pi over 5.